अच्छा चलिए सारों को आवाज आ रही है।
यस सर।
जी सर।
बस ठीक है, ये मैं मेरा स्टाइलिस इस पे काम नहीं कर रहा, वो इसलिए मुझे चेंज करना पड़ता है, वो मैं सॉर्ट आउट कर लूंगा वीकेंड पे। अच्छा सो वी कोई और तो अच्छा वी हैड लास्ट टाइम ना हमने ये किया था कि successive ionization energies, right? Which is that you're trying to remove electrons from the same atom. So removing the outer electrons was kind of easy. ठीक है, फिर inner electrons was slightly harder, और फिर सबसे inner shell वाले electrons was even harder. ठीक है, so you can use this to sketch successive ionization energies graph for pretty much any element. तो एक और कर लेते हैं. Let's say I've got fluorine. So fluorine has the fluorine atom has two shells. So there are 9 electrons in total. So you've got 2 electrons and then you've got 7 electrons. E hota hai na, 2 7, yes. So now in the case of fluorine, what will the ionization energies look like? So total kitna sketch kara? That's 9 ionization energies. So that's 1, 2, 3, 4, 5, 6, 7, 8. Okay, मेरे ख्याल से तो 9 वैसे ही थे. एक सेकेंड. ठीक है, 1, 2, 4, 5, 6, 7, 8, 9. Actually, in the case of fluorine, removing the electrons, the outer electrons, 7 of them is going to be easy. लेकिन वो successively ना, it's going to become hard, more difficult. ठीक है, so that's the first, then the second, फिर third, fourth, fifth, sixth, and seventh, right? So the ionization energy gradually increases. और फिर एकदम से when you reach the 8th electron, ठीक है, removing the 8th electron will all of a sudden become more difficult. So 8th or 9th पे ना there's going to be a huge jump. और 8th और 9th में ना कोई इतना ज्यादा फर्क नहीं होगा. ठीक है, तो फैक्टर्स पता होना चाहिए why there's going to be a jump. कि the outer electrons were easy to remove because the distance was larger and the shielding effect was larger as well for the outer electrons. Why were the ionization energies increasing? क्योंकि they were increasing because every time the net positive charge on the ion kept on increasing. ठीक है, why are the inner shells harder to remove? ठीक है, that's because the electrons have less shielding and they're closer to the nucleus. और फिर उनमें भी why is there an increase? Because the net positive charge on the ion constantly increases. चलो ये सारा क्लियर है.
यस सर।
जी सर।
अच्छा, तो इससे इससे आगे ये कि down the group. ठीक है, so the next thing is we're going to compare the first ionization energies down the group. But just the first. ठीक है, पहला electron remove करें, that's it. Now it's a comparison between atoms. वो तो एक ही atom है, so ना you were removing electrons. So first ionization energy comparison down the group. So when you're going down the group, तो उसमें क्या होता है कि like if I draw atoms and I pick any group, let's say I pick group 1. तो let's say this is the first atom. So that's lithium. Lithium has how many electrons? Lithium's got it's got 3 electrons in total. 3 बल्कि एक ज्यादा हो गया. अच्छा, it's got 3 electrons. ये तो बड़ा shell है इसके. अच्छा, 3 electrons plus it's got 3 protons as well in the middle. अच्छा, फिर you've got the other down the group, you've got sodium. तो sodium के पास कितने shells होंगे? Sodium is going to have 3 shells. So that's the first one. फिर ये second. And then it's got a third shell. So sodium will have 11 electrons. And sodium is going to have 11 protons in the nucleus. Acha, khair, wo trend, I'm not going to draw the other atom because the trend is quite obvious. The other atom is going to have an extra shell. So now you're moving down the group. So क्या होगा? Will it be more difficult? So you're trying to remove the first electron in both of these atoms, and you're trying to compare this. तो क्या होगा?
सर
Easier.
easier होगा ना, easier होगा.
ठीक है. So the first ionization energy, that's it. ठीक है. First ionization energy will decrease. Oh, पूछेंगे the factors. What are the factors? Why will it decrease?
Shielding effect.
ठीक है. So you've got shielding increases.
And nuclear charge increases.
अच्छा, पहले
Sir, distance between nucleus and outer electron
ठीक है.
increases.
तो shielding and distance of valence electrons वो एक ही point. मतलब ये दो अलग अलग points है, लेकिन I've just made it one point. ठीक है. Shielding and distance of valence electrons increases. ठीक है. So there are two factors. Both of these factors, they suggest that ionization energy will decrease. So you've got two factors which support ionization energy will decrease. There's one factor that's going against this. वो कौन सा?
Nuclear charge.
हाँ, nuclear charge, number of protons. ठीक है. So two factors outweigh that one factor. So which is why the ionization energy decreases. तो आपको इसको words में explain करोगे, which is कि the first ionization energy will decrease. Why? Because shielding and distance of valence electron increases. Hence, there is less attraction between nucleus and valence electrons. Despite the fact that protons are increasing, yet nuclear charge increases. ठीक है. So you have to mention this other factor which is going, ये जो nuclear charge वाला है. ठीक है. You have to mention this other factor, but वो basically it's outweighing the other. It's the other two are outweighing this factor. ठीक है. क्योंकि उसके opposite जा रहा था. A higher nuclear charge means that there's going to be more attraction, but because of the greater shielding and greater distance, you eventually have less attraction. ठीक है. Is this clear?
Yes, sir.
Yes, sir.
So ठीक है. So easy है ना. ठीक है. Down the group ionization energy decreases. That's it. First comparison में first ionization energy decreases. Now moving on. अब next है कि across the period now. ठीक है, तो again this one is a comparison of fast ionization energy across the period. And it's basically across any period. So across the period में होता है कि when you're going across the period, और atoms में कुछ draw कर लेता हूँ. So let's say I'm in period 2. So period 2 में I've got lithium, I've got beryllium, I've got boron, I've got carbon, nitrogen, oxygen, fluorine, and then I have neon. ठीक है. So when I'm moving across the period, I'm just going to draw, just because we just need to know the trend. So I'm just going to draw lithium, I'm going to draw carbon, and I'm going to draw fluorine. ठीक है, just to give you an idea of what the trend is. तो lithium को draw करना पड़ेगा, so that's ठीक है, that's 2 shells. Carbon is also going to be 2 shells, 2 6 2 4 होगा, 6 electrons in total. And fluorine will also have 2 shells, 2 and 7. So the first one, lithium, is 2 and 1, 3 electrons. Or you remember, you 3 protons and 4 protons, 5 protons, 6, 7, 8, 9, up here. I've got 10. अच्छा, अगला वाला, that's carbon is 2 and 4. And this fluorine over here is 2 and 7. अच्छा, plus the nuclear charge. This one has 3 protons. This one has 6 protons. And this one has 9 protons. ठीक है. अच्छा, वैसे बता दो कि what will happen across the period? Will it be harder to remove electrons or easier to remove electrons?
Say harder to remove
Easier.
electrons, right?
और चल, अगर more difficult है तो why is it more difficult?
Shielding effect.
Sir, I think वो atomic radius कम हो जाता है ना
नहीं,
उनका।
पहले शीलिंग से स्टार्ट कर लेते हैं.
तो
शीलिंग
इससे
क्या है?
मतलब more electrons होते हैं sir, more electrons across the period, मतलब फिर shielding effect.
शीलिंग तो होता है इनर शेल ना, कि न्यूक्लियस
हाँ
न्यूक्लियस अंदर है और आउटर इलेक्ट्रॉन, उसके बीच में हाउ मेनी शेल्स you've got. तो शीलिंग इज कांस्टेंट अक्रॉस द पीरियड.
The proton number
ठीक है,
increases.
तो ठीक है. नंबर 1, across the period the nuclear charge या proton number increases. अच्छा, शीलिंग क्या है? शीलिंग remains constant, right?
Yes.
Shielding cost क्यों?
मैं बताता हूँ एक सेकंड. कांस्टेंट ही है ना, कि आप ये देखो कि ये लिथियम है, राइट? दैट हाँ, अच्छा, ये लिथियम है, लिथियम का आउटर इलेक्ट्रॉन है, एंड दिस इज द न्यूक्लियस. तो बीच में हाउ मेनी इलेक्ट्रॉन्स डू यू हैव इन द मिडल? 2 इलेक्ट्रॉन्स, राइट?
Yes.
ये कार्बन है. यू आर ट्राइंग टू रिमूव 1 इलेक्ट्रॉन फ्रॉम कार्बन. तो इस इलेक्ट्रॉन में इन द न्यूक्लियस, बिटवीन द न्यूक्लियस, हाउ मेनी इलेक्ट्रॉन्स कमिंग इन द वे? 2 electrons, right? So number of inner shells kind of remain the same. ये अगले वाले में भी it's going to be कि you've got you're trying to remove this electron. अच्छा, so you're trying to remove this electron from the nucleus, and there are 2 electrons coming in the way. तो ये clear है कि shielding remains constant, right?
Yes.
Yes, sir.
अच्छा, plus एक और चीज है कि the distance also kind of, मतलब देखने में the distance also kind of remains constant. But the reality is कि distance जो है ना, it slightly or gradually decreases. और वो मैं एक्सप्लेन करता हूँ कि why does distance decrease. तो फ्लोरीन जो होगा ना वो साइज में थोड़ा सा छोटा होगा, ठीक है, और लिथियम जो होगा ना वो साइज में थोड़ा सा बड़ा होगा साइज में. अच्छा, and there's a reason for that. The reason is कि when you're moving to the right, see over here, ये जो फ्लोरीन है ना, it's got 9 protons. तो उसका जो न्यूक्लियस है ना, that's got a very strong attraction or hold on its electrons. तो वो अपने shells को ना, it tightly holds on to the electrons, so the electrons are like slightly closer to it. 9 protons है ना, इसका जो positive charge in the nucleus, that's almost 3 times greater than lithium. Lithium only has 3 protons. तो 3 protons जो है ना अपने outer electron को, it's not strongly holding on to its outer electron. So the outer electron over here in lithium is like slightly further away. लेकिन फ्लोरीन के केस में, because of the 9 protons, because of the much larger nuclear charge, the electrons are more strongly attracted to the nucleus, ठीक है. तो ये clear है, the distance kind of looks कि they all have the same number of shells, but the distance slightly decreases. Is that clear?
Yes, sir.
ठीक है सर.
So there's more protons, so there is stronger attraction for valence electrons. Acha, so nuclear charge increases means ionization energy will increase. Shielding remains constant, so that's not much of a factor. और जो आपका डिस्टेंस है ना, डिस्टेंस क्या स्लाइटली डिक्रीज कर रहा है, तो वो भी इंडिकेट करेगा आयनाइजेशन एनर्जी विल इंक्रीज, राइट? इज दैट क्लियर? तो
Yes, sir.
मतलब एक फैक्टर तो मैटर नहीं कर रहा, बाकी तो दे ऑल बोथ ऑफ देम आर स्टेटिंग दैट आयनाइजेशन एनर्जीज इंक्रीज. तो यहाँ पे आखिरी पॉइंट आप लिखोगे हेंस बिकॉज ऑफ दिस, तो हेंस देयर इज स्ट्रॉन्गर attraction between nucleus and valence electron. अच्छा, ये लाइन लाजमी लिखनी है आंसर में ना, मतलब जब वो पॉइंट्स देते हो ना तो एंड में फिर यू ऑलवेज हैव टू राइट हेंस देयर इज स्ट्रॉन्गर अट्रैक्शन बिटवीन, इसका एक अलग से मार्क होता है, between valence electrons and your nucleus, ठीक है. तो and first ionization energy increases across the period. ठीक है, ये क्लियर है across the period?
Yes, sir.
जी सर, एक मिनट है सर, ये नोट करना.
ठीक है, उसमें नोट्स में तो भेज दिए सारे, ठीक है, ग्रुप पे भी.
चलिए ठीक है,
Sir, I
थैंक यू
have a question.
हम्म.
जो like period can this में beryllium and boron and nitrogen oxygen these two are exemptions, right? Because उसमें
नहीं
slight
वो
decrease होता है.
नहीं वो उस पे मैं आता हूँ, वो अगला पार्ट वही है ना.
Okay.
तो अच्छा, रिमेम्बर, तो ये जो है ना, ये जो अभी हमने लिखा है ना, that's your general trend, ठीक है. Okay, when you move across the period, the ionization energies increase, ठीक है. तो remember this, whatever we've noted down right now, ठीक है, that's the general trend. So now the reality is things are not exactly this way. There is an increase, so if I make a graph, so so if I make a graph of this, generally it should increase. So I've got lithium, first one. अच्छा, लिथियम है, बेरिलियम है, बोरॉन है, और क्या था, ये बहुत करीब करीब हो रहे हैं, एक सेकेंड. अच्छा, लिथियम, बेरिलियम, बोरॉन, और कौन था, कार्बन, नाइट्रोजन, oxygen, fluorine and neon. ठीक है, ये फिर अपना माइक म्यूट कर ले. अच्छा, ये लिथियम बेरिलियम. अच्छा, group 1, group 2, group 3 and so on. अच्छा, now the trend should have been कि they should have been वो direct increase होना चाहिए था यूं करके. ठीक है, the first ionization energy should look like this. ठीक है, तो but this is not exactly the case. वो इस तरह होता है. The trend is something like this. अच्छा, कौन सा माइक आपका मेरे ख्याल से ऑन है? ये किसका ऑन है? अना मेरे ख्याल से आपका ऑन है. हाँ. अच्छा, now the trend is it should be increasing, but it's not increasing in a straightforward way. ठीक है, लिथियम से बेरिलियम it increases, boron पे it slightly decreases, then it increases again carbon and nitrogen. ठीक है, फिर oxygen के ऊपर it's going to decrease again, और फिर you're going to have fluorine and आखिरी रह गया neon. तो वो कुछ इस तरह करके. ठीक है, so there's going to be dips. So there's going to be dips at group 3 and group 6. So the trend is kind of followed. Generally it is increasing, but not, but वो straight line नहीं होगी. ठीक है, it's going to have dips. It's going to have dips at boron and oxygen. Or yeah, across the period now, it's always, if you pick any period, it's going to look exactly the same. ठीक है, there's going to be a dip at group 3 and there's going to be a dip at group 6. सारे period एक ही तरह के होते हैं ना. The shells remain constant. ठीक है, so pretty much all periods are going to have exactly the same thing, that they're going to have the same shielding, same number of shells होंगे. When you move across the period, the protons will be increasing, so the trend will be maintained across the period. अच्छा, so in reality the graph kind of looks like this. ठीक है, तो जब sketch करना है, it's going to be sketched in this way. So the next question is कि why is there a dip in ionization energy at group 3? But why is boron not following the trend, and why is oxygen not following the trend? ठीक है, तो अगला वो क्वेश्चन पूछेंगे कि why is the trend not being followed exactly. तो इधर ना हम इन दोनों का कंपैरिजन करेंगे, बेरिलियम एंड बोरॉन. तो क्वेश्चन ये होगा कि why is boron's first ionization energy less than यानी ग्रुप 3 वाला जो है ना, why is it having an ionization energy that's less than beryllium, which is group 2, because it's not following the trend. So the answer to that is कि when you look at boron, दोनों का ना इलेक्ट्रॉनिक कन्फिग्रेशन कंपेयर कर लेते हैं. I think beryllium has 4 electrons and boron has 5 electrons. Beryllium is what, 1s2, 2s2. अच्छा, यहाँ पे खाली ना सबशेल्स की बारी आती है. ठीक है, you have to mention subshells. Boron is 1s2, 2s2 or 2p1. अच्छा, so what happens is कि in boron the electron is removed from a subshell which is slightly further away and slightly more shielded, क्योंकि अब ज्यादा सबशेल्स आ गए ना. तो जब आप ग्रुप 2 से ना you move to group 3, so we know electronic configuration, another subshell gets added. So shielding slightly increases, the electron becomes further away from the nucleus because now it's in a subshell which is वो अगले वाले subshell में आ गए. So which is why it kind of becomes easier to remove electrons from the 2p subshell. ठीक है, because of the slightly higher shielding and slightly further distance. ठीक है, तो boron से electron remove करना, it becomes very slightly easier. So which is why you're going to see a dip at boron. या कभी भी आप ग्रुप 2 से ग्रुप 3 पे जाओगे ना अक्रॉस द पीरियड, यू गोना सी दिस स्टेप। तो ये बात क्लियर है, ये मैं लिख देता हूँ, लेकिन इज दिस क्लियर?
Yes, sir.
जी सर।
ठीक है, सो रिमेंबर इट्स अ वेरी फेवरेट क्वेश्चन आई एम गोना आस्क यू अ लॉट, ठीक है, कि भाई ग्रुप 3 पे कम क्यों हो रही है। तो व्हाट यू गोना राइट इज कि इन बोरॉन the electron is removed from a higher energy uh, 2p subshell, which is more shielded and further away as compared to your 2s subshell. So was slightly more shielded, so it's why it's well, hence वो भी लिखना है, hence easier to remove electrons. In boron. ठीक है, is this clear?
जी
Yes.
सर।
और ये याद रखना, कोई भी मतलब किसी भी पीरियड में ना ग्रुप 2 का outermost shell is always S2 and group 3 is always S2p1. तो in any period group 3 will be slightly easier to remove electrons. अच्छा, ये तो ये वाला हो गया, और इसको अंडरलाइन कर लें। अच्छा, the other one is कि there's another dip, ठीक है, which happens at group 6. कि भाई what went over here, ठीक है, at group 6, कि why is group 6 easier to remove electron in group 6 compared to nitrogen? Why is it not following the trend? तो group 6 और group 5 को देख लेते हैं। तो क्वेश्चन ये होगा कि why is oxygen's first ionization energy less than nitrogen? यानी why is group 6 less than group 5? So again, इसमें भी ना you're going to focus on the ionization on the subshells. कि nitrogen के ऊपर होते हो ना आप, when you're at nitrogen is 7 electrons, sorry. That's 1s2, 2s2, और 2p3 होता है, ठीक है। जब आप ऑक्सीजन पे आते हो ना, ऑक्सीजन इज 8 electrons, ठीक है, so that's group 6 का पता होना चाहिए, it's going to be s2p4. तो 1s2, 2s2, and you're going to end up with 2p4. So when you move across a period from group 5 to group 6, group 5 पे you had p3, group 6 पे you're going to have p4. अब होगा ये कि when you move from ये p3 to p4, रिपल्शन होगी, ठीक है। रिपल्शन इसलिए होगी कि p3 means that px, py, pz, they all have 1 electron each. अलग अलग orbitals and they all have 1 electron each. But when you have p4, that means कि px, py or pz. So spinner, the first one is going to have 2 electrons. So what happens is कि when your orbital has 2 electrons, the electrons will kind of repel each other, and that will kind of make it easier to remove electrons from oxygen. वो थोड़ा ज्यादा overcrowded हो गया ना आपका p orbital, right? तो
Sir, is this spin pair repulsion?
हाँ, this is known as spin pair repulsion. हमने कहा था कि opposite spins होती हैं orbital के अंदर, right? तो group 6 के ऊपर your p orbital becomes overcrowded. Okay, now an orbital has two electrons and they will repel each other. So it will kind of become easier to remove electrons. तो वही आप लिखोगे कि इसकी जो explanation होगी कि in oxygen electron is removed from a paired p subshell. Compared to N, which has unpaired p orbitals, या p subshell. तो फिर रीजन वही लिखोगे, so due to electron repulsion या due to spin pair repulsion. ये चीज क्लियर है? This one.
Yes,
जी
sir.
सर।
तो बस ठीक है, ये आपका ना कंप्लीट हो गया, मेनली तो कंप्लीट हो गया across the period. We're done with across the period. So remember the general trend is okay, the ionization energy continue to increase across the period. Protons increase. You've got the shielding remains constant. Distance slightly decrease करता है. But there are going to be dips at group 3 and group 6. Why is there a dip at group 3? Because at group 3, you are removing electron from a slightly higher energy p subshell. So it kind of becomes easier to remove electrons. Or why is there a dip at oxygen? Because when you're removing electrons from oxygen, you're now removing electrons from a p which is overcrowded, which has too many electrons. So removing electrons from a paired p orbital is going to be easier. ठीक है, वो there's going to be spin pair repulsion और electron repulsion. ठीक है, इसी जगह electron repulsion भी लिख सकते हो. ठीक है, so it kind of becomes easy to remove electrons from oxygen. तो ये दो exceptions है. अच्छा, फिर ये कि एक बस आखिरी चीज है, वो ये कि अक्सर ना वो कंसेक्टिव प्रोटॉन नंबर्स की बात करता है. अच्छा, व्हाट वुड द ग्राफ लुक लाइक? तो एक ग्राफ में बाद में शो कर लूंगा, वैसे तो हमने कर लिया. विल डू पास्ट पेपर्स नेक्स्ट टाइम. ठीक है, तो वो ग्राफ इतना इंपॉर्टेंट नहीं है, वो मैं अभी ड्रॉ करना मुश्किल होगा इसके ऊपर. मैं ये वीकेंड पे सॉर्ट आउट कर लूँ ना, इसकी पेन का इशू क्या है. तो
Can you send these notes?
हाँ, नहीं मैंने नोट सेंड कर दिया उस पर ग्रुप पे.
Okay.
ठीक है, वो एग्जैक्टली यही है. ठीक है, तो वो फिर नेक्स्ट टाइम ना, जस्ट रिमेंबर इसके ना जो इसके इसके पास पे क्वेश्चंस विल बी स्लाइटली ट्रिकी. नॉट दैट ट्रिकी, लेकिन विल बी ट्रिकी. ठीक है,
ठीक है सर.
चले ठीक है, मंडे को कंटिन्यू करते हैं. ठीक है,
ओके सर.
ओके
ओके,
सर,
अल्लाह
अल्लाह
हाफिज सर.
हाफिज।
ओके, अल्लाह हाफिज.